Welcome to CIT 160 and our discussion today on Chapter 1. Chapter 1 is going to be about computer hardware. My name is Brother Ferguson, and I'm going to lead the discussion today. Let's move on to the PowerPoint that we have here. Good. All right, computer hardware. So in this chapter, we talk mostly about just the basics of what's going on inside the computer. We'll go into a little bit of electronics. We'll go into the major components and a little bit of how it all works. Okay, so just to get started here. Okay, so we're going to start talking about the semiconductors, or the most basic parts of the computer. The first one is the capacitor. The capacitor is, you can think of it as like a little battery because it stores electricity. It just sometimes in electronics you need to store a bit of electricity and release it all at the same time. And so the capacitor is kind of what does that. You can increase voltages and things like that, but most of all, just think about it as a little mini battery. The next thing is the diode. Diode you can think of as like a one-way street. It only allows the electricity to go through it one direction, but not the other. But if you think about it like a one-way street, it only goes one direction. That's pretty much what a diode is. It's so that the power can't go backfill into the circuit that when you don't want it to. Light emitting diode is just a special diode, and we all know about light emitting diodes. We call them LEDs. It's just a diode that when the electricity does go through it, it creates light. And so we use that all the time in our lighting and in our houses and in computers and stuff like that. So that's what it's just a diode that emits light. Integrated circuits. So an integrated circuit is like a microchip. It has a lot of different components all built up into one, and it's usually etched into some silicon. So it does a lot of things all in one chip. And so that's what an integrated circuit is. It's integrated. It's many circuits that are integrated into one chip. Power supply. Basically, all the power supplies turns your alternating current that comes out of the plug in your house into direct current, which is what the computer needs for its electronics. And so the power supply does that conversion from AC to DC. Keyboard, it's an input device. It allows the user to then input information into the computer through typing. So that's what a keyboard is, an input device. The motherboard. The motherboard is kind of the main board where all the different components of the computer plug into. So your power supply is going to plug into that. Your graphics chipset is going to plug into that. It's the main board, or the motherboard, that everything kind of connects into all at once, and then allows the different parts to go talk to each other. The BIOS is a little tiny computer program that runs inside your computer that does just the very basics. So it tells the computer how to talk to the hard drive. It tells the computer how to talk to the video card. It tells the computer how to talk to the monitor. And so it's very basic, very low level. And then your operating system sits on top of the BIOS and then interfaces between applications and the BIOS, which then talks to the hardware of the computer. So the BIOS is just some very basic software that sits on your computer that allows your software to talk to all the hardware parts. The CPU is called the central processing unit. The central processing unit is the main brain in the computer. It does all the processing. So it does all the math. It does all the code programming execution. But it's the main brain inside the computer. Sometimes people call the towers, computer desktop tower a CPU, but that's not entirely true. The CPU is just the chip on it. It's usually made by a company like AMD or Apple or Intel. And it's just the main processing chip that's on that's on the computer. Cache. Cache is just a little bit of memory that's very close to the CPU. That's really fast. So it's not your main memory in your computer. The RAM that you think about that usually comes in 8 gigabytes or 16 gigabytes. It's a very small chunk of memory that the CPU can use just really quickly back and forth, so that it can do its calculations really fast. And so that's the cache that sits next to the CPU. The main memory, like we were just talking about a minute ago, is where your programs sit and where it can store information for it to use. It's not the cache, but that's just used temporarily very quickly. Main memory can be used for a longer period of time, but the main memory goes away. It's volatile. It goes away if you turn off the computer. And so, but it's used by the computer in your applications to while the computer's on, while your programs are running. The hard drive, it stores data more permanently. So if you save a file like in Microsoft Word onto your hard drive, it'll stay there even if you turn off the computer and turn it back on. And so that's what the hard drive does. It usually has magnetic platters inside of it. More newer versions of hard drives are called SSDs, and they're all electronic, but they basically do the same thing. It's a more permanent form of storage. You can delete things, you can erase things from it, but it's not going to go away when you turn off your computer. Thumb drives, jump drives, flash drives, lots of names for the same thing, but it's just electronic memory, like a hard drive, like an SSD, that you plug into your USB port, and you can save things and you can port it from computer to computer. Monitor, another output, or this is an output device. This is where you can see things that are happening on your computer according to the application that you're running. And so the monitor is like one of the main kinds of output devices. Other kinds, printers, or or another common type, but monitor is your main kind. Now you don't have to necessarily have a monitor for computers, but for the most part, from what from our main experience, we have monitors. Okay, a bit. So now we're looking at data sizes. A bit is the most basic piece of information a computer can hold. It can hold either a 1 or 0, a true or false. It's either yes or no. Okay, a bit is represented usually by a 0 or a 1. Computers are binary systems. That means they only understand ones and zeros. And that's because of the hardware, because the way the computers work. Really on the inside, there's just a whole bunch of, think about a whole bunch of tiny little light switches, and those light switches are either on or off. And by putting those together in big long chains, you can represent numbers and represent letters and things like that. But the bit is like a single switch. It's either yes or no, or it's either on or off, or it's either a 1 or a 0. Okay, you can see in this picture the little bracket here that signifies it's the 1 or the 0. It's one piece of information. Now to go up a size, you have a nibble, and a nibble is 4 bytes together. Okay, and that represents a certain number of the range of numbers, but it's represented by 4 bits in a row, which is called a nibble. Now, if you go 8, it's called a byte. Now you can kind of see where this is going. It's kind of fun. A nibble is like a little bit of information, or like a little tiny byte, and 8 bits is a whole byte. All right, and so it can hold numbers from 0 to 255. I think a nibble was 1 or 0 to 128, something like that. But that's kind of the number range you can represent. Then we get into the big ones. All right, a kilobyte. So if you know your metric system, kilo means 1,000. So a kilobyte is 1,000 bytes. Now, it's not exactly 1,000 bytes because computers use binary. That means it has to be powers of 2, ones and zeros, right? And so it's technically 1024 bytes, but it's about 1,000. That's why they call it a kilobyte. Likewise, megabyte, not exactly a million. Mega means million. It's not exactly a million, but it's about a million bytes. Gigabyte, another 3 orders of magnitude. So that's a billion bytes or thereabout. A terabyte. So now we're getting to trillions. Petabyte, quadrillions. So we're getting really big. So these are huge numbers that you can represent in a petabyte. So if you have like many gigabytes, many gigabyte hard drive, until you get to, a petabyte, you can store a lot of information with that. Exabyte, quintillion, I think. It comes after a quadrillion, another 3 orders magnitude larger. It's called an exabyte. Okay, that's as high as we go there. Next is clock speed. So clock speed, computers need everything to happen at precise moments in time, so that when the CPU is expecting some information from maybe the cache or maybe the memory, it looks for it at very specific intervals. And those intervals are called the clock speed. So you'll notice when you buy a computer, a lot of times there'll be a clock speed associated with it. A processor that runs at, say, 2 gigahertz. The gigahertz is the clock speed. So as we, you have kilohertz, megahertz, gigahertz. So that's millions of, or billions of cycles. Now, one instruction in a processor can happen per clock cycle. All right. So if you have a 2 gigahertz CPU, that means it can process 2 billion instructions and computer commands within 1 second. Now that compounds if you have multi-core processors like the i5s and the i7s of Intel. So they have say you have a quad core processor. So instead of 2 billion instructions per second, if you have a quad processor, it's 4 times that potentially. And they happen at the same time. So each core is like a little mini processor that can be functioning at the same time. All right. And they happen exactly at the same moment because they use the same clock. All right. So if you have a single core processor running at 2 gigahertz, you can do 2 billion processes or instructions per second. If you have a quad processor, that's 8 billion instructions per second. All right. So just know that you have your clock speed, but then you have to multiply it by the number of cores that you have for how many instructions per second that it can process. Okay, so here's just more of that information I was just going over. A hertz, that's 1 cycle per second. Megahertz is 1 million, and gigahertz would be 1 billion. Different computer classes. There's the micro personal computer. Those are the ones we normally deal with. Your laptop, your desktop, things like that. Workstations are usually like a desktop, but they're super powerful. They usually have, exceptional graphics or really fast processors, and they're usually used for engineering work and things that take a lot of processing. Mainframe, big computers in a big room that do tons of work all at once, usually at universities, businesses like insurance companies, healthcare companies, things like that will use mainframes because of the computing power that they need. Application, that's a computer program that runs on top of the operating system that runs on the computer. So say you're running Microsoft Word, that's an application. If you're running iTunes, that's an application that runs on the computer. The operating system, we talked about that a second ago, that's the go-between between an application and the BIOS. So the application doesn't have to know anything about the BIOS. It just talks to the operating system, and then the operating system kind of takes care of that. The operating system is kind of the go-between. It's the base software that's on the computer that sits on top of the BIOS, but underneath your applications that you're running. So finally, we have character data. So we talked about how bits and bytes can represent numbers, but how those numbers represent um, letters and stuff like that. And what they do is they do something called encoding. And so what they do is say, okay, this number represents a letter, and this number happens to be 128. Okay. So then you have a table that goes and you look down the table and 128. Well, I'm sorry, that was a bad example because it's not even on the table. Say the number is 78 right here. And that number 78, when it's representing a number or a letter, sorry, it represents an H. Okay, likewise, 84 represents a T. 70 represents an F. And so those are the numbers that represent the different characters, the different letters. Now, it started with ASCII, which is the American Standard Code for Information. And it was really good for punctuation and letters generally for Western languages. As we all know, there's lots of languages out there. They with lots of different characters. 128 wasn't enough, and so they came up with Unicode. And so instead of just using 1 byte, it uses 2 bytes. And so because it uses 2 bytes, there's a lot more numbers available to represent different characters and different punctuation and things like that. And so we use the Unicode in order to, and it supersedes the ASCII so that we can handle more characters for more languages across the world. All right, that's it for Computer Hardware Chapter 1. If you have any questions, please let me know.